Master, thank you club, and esteemed guests. I am about to give a very, very difficult speech. By the end of these 6 minutes, I hope that you will have a conceptual understanding of Einstein's theory of relativity. Okay? So be prepared to stretch your mind and as we begin this journey, okay? So, basically Einstein's theory of relativity says that if I were to go on a rocket, go really, really fast into outer space and then come back, I may be the same age, but 50 years pass by on Earth, okay? That's the basic understanding. So here we go. Why is relativity practical? Well, I know a lot of you guys, and we like to travel, you know, go on missions, go on vacations, see the world. Well, after exploring all 4 corners of the Earth, and after reaching all the unreached people groups and evangelizing to everyone on Earth, what are you going to do? You may want to consider deep space travel, okay? You know, evangelize to the aliens. As our acting president said, he wanted to be an astronaut, so this is very practical for all of us. Or maybe we just want to simply impress our friends with the knowledge of such an intimidating topic. You know, when that Star Trek movie comes out, your friends might be talking about relativity, and you don't want to act dumb, okay? So, just kidding. So, if we gain an understanding of this difficult topic, you can pretty much learn anything. And this knowledge, it'll not only help us understand how our universe works, but it'll help us appreciate God's majesty and His mystery, because God created physics. God created physics. So let's begin. The premise of relativity comes from this one idea, okay? The idea is that light travels at a constant speed no matter who is observing. Example, I'm standing still, light is coming to me, the light comes to me at a constant speed. If I'm running, the light comes to me, from my point of view, at the same speed. If I am running half the speed of light, the light speed compared to me is still the speed of light. Okay? This is a little counterintuitive. It doesn't make sense to us. But if I'm going almost the speed of light, the light speed compared to me is not, we're not going the same speed. The light speed is still going the speed of light compared to me. Okay, so we have to understand this before we go on. Does that make sense? If I'm going the speed of light, the light is going the speed of light faster than me. If I'm standing still, the light speed is going the speed of light faster than me. And that speed of light is a constant. Just for your curiosity, it's 670 million miles per hour. Okay, so we have to accept this before moving on. It's counterintuitive, but it's been proven physically. They've done experiments, and the light speed is constant. And they've done it using equations. But it's constant no matter who's observing, no matter how fast you're moving, it's the same. So now, this is where Einstein's thought experiment began. He devised this thing in his head. We'll call this a light clock, okay? This is a light clock. There's a flashlight right here, a mirror up here, and a little sensor right here. So what happens is I turn on the light, it goes up, and it comes down, and then when it hits this, I record the time, how long it took to go up and then down, okay? So we begin, so from my point of view, I turn on the light. Goes up, goes down. Let's say it took a second to do that, okay? 1 second. So when I'm looking at it, I turn it on, it's 1 second, right? Now, pretend I'm going really fast. I'm moving, and as I'm moving, I turn it on. Now what happens really is, I turn it on, I'm moving, and it goes back. So from my point of view, it's 1 second. But from your point of view, the light moves that much. And if light is constant, it takes longer time, from your point of view, for this same event to occur. Therefore, what happens to me is 1 second, I'm viewing it, it goes up and then down, 1 second, but for you, you are viewing a situation that is 10 seconds long. Because light had to travel a greater distance. So from your perspective, light traveled 10 seconds because it's a greater distance. From my perspective, it only travels 1 second because I'm viewing it and it only happens 1 second. Now, if you extrapolate this to a rocket, I attach myself to a rocket and I go to just the farthest galaxies, and then I come back. I may still be 19 years old when this happens, but then when I come back, everyone's 50 years older. So, it's a way to time travel. So, now that you just grasped this tiny little piece of what this theory of relativity is, we can do a few things with it. One, you can pioneer a deep space program, or you can just watch Star Trek, and then you can talk to your Trekkie friends about it, engage in intellectual conversations, or you could simply just gain a revived awe of God and recognize that He is even more mysterious and more complex than the universe, which is so complex, and He's just so much more greater than we can ever imagine. Thank you very much, and I will return it to Ms. Tesmas.